In the last video, you learned how to draw the Lewis structures for covalent molecules. These molecules take specific shapes, determined by how many atoms are bonded to the central atom and by how many lone pairs are on the central atom. In this video, you will learn how to determine the shapes of certain covalent molecules. Lewis dot structures do not tell us what molecules actually look like in three-dimensional space, so we use the Vesper theory to help us determine the shape of the molecule. Vesper stands for valence, shell, electron, pair, repulsion. The Vesper theory states that the geometry or shape of a molecule is determined by the electron pairs repelling each other. Remember, electrons are all negatively charged, so they are going to move as far apart as possible. To determine the shape of a molecule, write the AXE formula. The A represents the central atom. There will only be one atom designated with an A. The X represents the number of atoms bonded to the central atom. They may all be the same type of atom, or they might not. The E represents the number of lone pairs on the central atom. We don't care about lone pairs on any atom other than the central atom when determining the shape of the molecule. It is the electron repulsion between the atoms bonded to the central atom and between the lone pairs which determine the shape of the molecule. If there are only two atoms in the molecule, the AXE formula is always AX, and the molecule is always linear. This is true no matter if the two atoms are of the same type, as in chlorine, or different, as in HI. In molecules where there are two atoms bonded to the central atom, but the central atom has no lone pairs, the molecule is once again linear. Boron is another element that, like hydrogen, does not want a complete octet. Boron only wants 6 electrons total, and it will typically form trigonal planar molecules. If 4 atoms are bonded to the central atom, and the central atom has no lone pairs, the shape is tetrahedral, which is basically a pyramid with a triangular base. If 3 atoms are bonded to a central atom with 1 lone pair, the shape is trigonal pyramidal. The central atom is forming the peak of the pyramid, not one of the atoms bonded to the central atom. The yellowish circle is a lone pair. If 2 atoms are bonded to a central atom with 2 lone pairs, the shape is referred to as bent, and we typically draw the molecule in a V shape. The 2 yellow circles in the model are the 2 lone pairs. To determine the shape, you must look at the Lewis structures. Chlorine has only 2 elements total, so you simply label one element A and the other element X. It does not matter which is which, and lone pairs are unimportant in this case. Because the AXE formula is AX, the shape is linear. The nitrogen is the central atom A in ammonia, and the hydrogens are the X's. Nitrogen has 1 lone pair on it, so label the lone pair with an E. The AXE formula is AX3E, so the shape is trigonal pyramidal. In carbon dioxide, carbon is the central atom A, and the oxygens are the X's. Carbon has no lone pairs, so there are no E's. Remember, we only care about lone pairs if they are on the central atom. The AXE formula is AX2, so the shape is linear. Pause the video while you look at the structures you drew for video 4. Write the AXE formula and determine the shape of each molecule. Continue the video when you are ready to check your answers. In this video, you learned how to determine the shape of covalent molecules. Thanks for watching.